Okay, Bismillahirrahmanirrahim. I will try to, inshallah, we'll start 5.6, undetermined forms and L'Hopital's rule. We have this extended mean value theorem. If you have f and g are differentiable, two functions differentiable, continuous, they're continuous in the closed interval, differentiable in the open interval, like the conditions for the mean value theorem, but also I need the g prime not equal to 0. Then there exists a c, perhaps f prime at c at g prime of c equal this. And if you notice, if we are doing it, yeah, just I have this relation. Okay, maybe we'll do some problems when it comes to the questions from the book. Okay, what is the L'Hopital's rule? Actually, we have these forms. These are the forms of the undetermined forms. They have 0 over 0, and they have infinity over infinity. This is, and they have 0 times infinity. We call it undetermined forms. But what they mean by undetermined forms means, the limit, it can be any value, undetermined. So we need to do something to fix it, to find the limit. So I have 0 over 0, infinity, infinity. This is the main things for L'Hopital's rule. Also, I have 0 times infinity. Now they have these three cases for the power. If I have function to the power function, these are the three cases, and they have infinity minus infinity. So these are the undetermined forms. Yeah, we can call 1, 2, 3, 4, 5, 6. 4, 5, 6 are only for the power, okay? And this is 7. If you have this form, these ones, I will try to make it like this one, 1 and 2. If 0 over 0 or infinity over infinity. And for example, so I can apply L'Hopital's rule. Notice L'Hopital's rule will be applied if you have function over function. You have function over function, and the function is continuous and differential. And open interval containing c except possibly at c. As usual, the limit we don't care about c, about the value at c. It's defined or not defined. And g prime not equal to 0. The denominator not equal to the g prime denominator equal to 0. If the limit as x approaches c, produce the undetermined form 0 over 0. And the same thing for infinity minus infinity for infinity, infinity for minus infinity. We can call it infinity category. When I say infinity for infinity, I need plus or minus. It's okay. Then what will happen? The limit of f of x, limit x goes to c, f of x over g of x, this limit is the same as this limit, f prime over g prime. So I change the problem. Instead of dealing of f over g of x, I will deal with f prime of g over g prime at x. And check, can I find it? Can I do? It will be easy limit. I can't find it quickly, or I need to do some manipulation. I get the answer. So it means the problem will change from this to another problem, another limit problem. There are cases where L'Hopital's rule will not work, will give you nothing. It will go, you will go in a cycle. But in general, you can use L'Hopital's rule if I get 0 over 0 or infinity infinity. What do you mean we can use it? I will change this problem to this problem. And then I check the new problem. It will work. We can find the limit or not. As I said, I have function over function. So I have 0 over 0 over infinity to infinity. This is the first step to check. And I have 0 over 0 or infinity over infinity. If it is in these 4 cases or 5 cases, I need to change it to this. Always L'Hopital's rule, you have function over function. So you can differentiate the numerator alone and the denominator alone. Okay, this is the same thing. So for this is the main case. It was 0 over 0 or infinity over infinity. The type, huh? When I say infinity over infinity, I'm considering minus infinity over infinity, infinity over minus infinity, minus infinity over minus infinity. That will not make a difference. Okay. So we have the type 0 over 0 or infinity over infinity, where I can apply L'Hopital's rule directly. I'm changing the question. Instead of finding this limit, I will deal with this limit, where I'm supposing that this limit will be easier. Try to solve it. Now we have this case 0 times infinity. I need to make it function over function. So I have, instead of dealing of f times g, I will deal with the limit f over g. I have fg. I will change it either f over 1 over g or g over 1 over f. So now I have function over function. Now I have function over function. I can apply L'Hopital's rule. Check. After checking, you have 0 over 0 or infinity over infinity. This infinity minus infinity is still the same thing. I need to manipulate the calculation to make it in this form. Infinity function over function. Always I need function over function when I have infinity over infinity or 0 over 0. The three cases of the power function to the power function, if you notice, I will deal, instead of dealing with this function, I'll deal with ln of y. That give me g of x, ln f of x. So the limit, as this goes to a, for example, of ln y will be this limit. And if you notice, these three cases, if we put f goes to 0 and g goes to 0, you have 0 times infinity. All these three cases, you have 0 times infinity, this limit. So it's undetermined form, because these are the only three cases where I'm getting undetermined form. Then what you will do, you will get this limit. You calculate it like this case, make it function over function, and then do the calculation. If we get L, notice I'm doing the limit of ln y, not y. So that means the limit of y as x goes to a will be e to the power L. Okay, what is here? E to the power L. That's mainly the thing. So I have 7 cases. These direct, خلاص. I differentiate the numerator alone and the denominator alone. Okay. So I'm having a new limit. I need to check that limit can be easy solve or I can manipulate it easier. Also, don't forget, always we can do L'Hopital's rule many times, no problems. If I have 0 over 0, infinity, you can apply L'Hopital's rule. And the case 0 times infinity, I change instead of product because I don't have L'Hopital's rule, it will not work for the product. I need to make it quotient. So either I change it f over 1 over g or g over 1 over f. The same thing, infinity minus infinity. I need to change it function over function. So I have either infinity over infinity or 0 over 0. And the last case for the power, I say these are the three undetermined forms: 0 to the power 0, infinity to the power 0, 1 to the power infinity. And we notice if I do the limit for ln y, if I get L, so the limit of y as x goes to a, it will be e to the power L. These are the main things for this section. Always we need to verify the condition first. We have 0 over 0, infinity, infinity. Don't do it blindly. No. And for example, this one, you have 1 over 0. So you have either plus or minus infinity, depends from right or left. But you cannot apply L'Hopital's rule. You're getting a wrong answer. Okay. So you apply the rule if you have 0 over 0 or infinity over infinity. Okay, this is one thing. The other things, the rule can be applied for x goes to plus or minus infinity, from left, from right is the same. You differentiate the top and the bottom separately. You can't do it more than once. Repeated sometimes lead to unended cycle. For example, this one, if you differentiate, this you go down, this will go up, then do it again, then it will go back. So you're going nowhere. So sometimes it will not work. These are quick examples, just to be sure we understand the problem. First, substitute. You have e to the power 0, you have 1 minus 1, so it's 0 over 0. Halas, it's ready. So now this one, this limit will be limit x goes to 0. I differentiate the numerator separately and the denominator separately. Huh? Each one I separately differentiate it, alone. So what's the derivative of the numerator? It will be 2e to x. What's the derivative of the denominator? 1. So this limit, what L'Hopital's rule is doing? saying this limit equal this limit. That's it. Now this new limit, can you find it? Check. Yes, I can find it right away. That will be 2e to the power 0, which is 2e to the power 0 over 1. That will be 2. خلاص. So that is the limit. So L'Hopital's rule is doing what? Only telling me in this limit is the same as this limit. That's it. Nothing else. Now check the new limit. Is easy to do or not? Check it. The same thing here. I have infinity over infinity. So differentiate the derivative in numerator 1 over x, the denominator 1. Substitute, we're getting 0. That's it. So I can't find it. As I said, L'Hopital is doing what? Just telling me, no, this limit is the same as this limit. But the new limit, you can find it easily. Same one here. I have 0 over 0. So differentiate. You get what? 1 over x over 1. So you're getting what? 1. You're getting 1. Okay. So that will be the answer to these problems. Okay. I think they are easy ones. Okay. Let me do more problems. Yeah, ln x over square root of x. If we do that, will be infinity over infinity. Differentiate. So this limit will be equal limit x goes to infinity. 1 over x is 1 over 2 root x. Don't apply the limit here. I need to manipulate this limit. Write it in an easy way. That will be what? 2 root x over x, or in other words, this is 2 over root x. Okay. Yeah, and you have x to the power half over x, which is x to the power minus half, so it will be 1 over root x, or 2 over root of x. That do the limit, you're getting 2 over infinity, which is 0. So the limit is 0. Okay. As I said, there was a 0 doing what? Just telling me, no, this limit is the same as this limit. Now do the calculation, manipulate it, we can get the answer. This one, same idea. If we substitute, you have infinity, e to the power minus infinity, which is e to the power infinity. So I have infinity over infinity. So I will do L'Hopital's rule. I'm getting what? 2x over minus is minus x. Now, if I apply minus infinity, I'm getting what? Minus infinity over minus infinity. I don't care plus or minus, but the category, we call it infinity over infinity. Okay, so I can apply L'Hopital's rule again. X goes to minus infinity. You have 2 over e minus x. Now apply the limit. I have 2 over e to the power infinity, which is 2 over infinity, and the answer is 0. The answer should be 0 in this case. Okay. Yeah, I'm trying to be sure and know what the calculations are. Okay, I think this is easy ones. Now let's double check. This one, yeah, it has some calculation. First, I check tan 0, 0 minus 0, that will be 0 over 0. So I'll check the limit now. I differentiate the numerator. I have secant square minus 1 over 3x square. Okay, if I substitute, I'm getting what? 1 minus 1, you have 0 over 0. I can do L'Hopital's rule again, or I can try to manipulate this one. Try to simplify it. If you notice, this is secant square minus 1. I know in 1 plus tan square is equal to secant square. So secant square minus 1, that will be tan square. If we do this, that's now I can use the special limit where I have tan. I have this one, I can rewrite it 1 over 3 tan x over x tan x over x. So it's tan square over 3x square. This is, I know this limit as it goes to 0. This is 1, and this is the same. So I have 1 over 3 times 1 times 1, and that will be 1 over 3. So what L'Hopital's rule is doing, just changing this limit to this limit. Well, this one I can't do it. You can't do L'Hopital's rule again here since I have 0 over 0, and you can't get the answer directly. This one, be careful. We apply L'Hopital's rule only if I have 0 over 0 or infinity over infinity. Don't do it blindly. If I do the L'Hopital's rule, I'm getting a wrong answer. Because when I do the limit here, I have sine pi, which is 0, and 1 minus minus 1. So I have 0 over 2, which is 0. No need for L'Hopital's rule here. L'Hopital's rule will give you wrong answer. It will give you wrong answer. Why it will give you wrong answer? Because we'll apply L'Hopital's rule only if I have 0 over 0 infinity, which I don't have in this case. So no need for no L'Hopital's rule here. No L'Hopital's rule. Yeah. In this example. Okay, I need to evaluate these limits. Just to be sure no mistakes. Okay, let me do it one by one. First one, I have space. Okay, so I have, actually this you can do it by factoring, but let's do it by L'Hopital's rule. Limit x goes to minus 2, x plus 2 over x squared plus 3x plus 2. First I check, I have 0 over, this is 4 plus 2 minus 6, 0 over 0. خلاص. So this will be limit x goes to minus 2, derivative of the numerator 1, the denominator 2x plus 3. Substitute. What are you getting? 1 over minus 4 plus 3, that will be minus 1. Okay. 2, limit x goes to infinity, e to the power x over x cubed. Check, that will be infinity over infinity. Differentiate, I can do L'Hopital's rule. I have e to the power x over 3x squared. Check, I have infinity over infinity. I will do it again. That will be limit x goes to infinity, e to the power x over 6x. Check, I have infinity over infinity. That means I can do it again. So I have limit x goes to infinity, e to the power x over 6. Now, apply the limit. You have what? Infinity over 6, which is infinity. So it's infinity. Yeah, this is equal. Okay, so that means in this limit is equal to infinity. 3. This is 3. 2. I did 3 before 2, no problem. This is 2. Limit x goes to 0 from right, ex minus 1 over x cubed. Substitute, I have e to the power 0, which is what? I have e to the power 0, which is 1 minus 1, 0 over 0. So do the limit. I have a limit x goes to 0 from right, e to the power x over 3x squared. Now, if I substitute, I'm getting what? E to the power 0, which is 1 over 0. That will be plus infinity. خلاص. I'm done. Let's stop here. Okay. 4. Limit x goes to infinity, x over ln 1 plus 2x. First check, I have infinity, numerator. 1 plus 2 e to the power infinity. This is infinity times 2 infinity plus 1 infinity. As I said, L'Hopital's rule just changing the limit. So limit x goes to infinity, 1 over derivative of the numerator. Derivative of x is 1. Now the derivative of this, which is 1 plus 2 e to the power x times the derivative of this, which is 2 e to the power x. So that one is the limit as this goes to infinity, 1 plus 2 e to the power x over 2 e to the power x. If you check the limit, you have what? Infinity over infinity. Okay, do it again. I have limit x goes to infinity. Differentiate denominator 2ax over 2ax, and that me 1. That limit is 1. Okay, limit of 1, which is, you can do it in 2 steps. Limit of 1, which is 1. 5. Limit x goes to 0, which we know it. But now we'll use L'Hopital's rule. That will be 0 over 0. So differentiate. You have cosine x over 1. Substitute. You have cosine 0, which is 1. That gives me 1, which I know. 6. Limit x goes to pi over 2. 1 minus sine x over cosine x. Substitute. You have 0 over 0. Sine pi over 2 is 1, so it will be 0 over 0. I can apply L'Hopital's rule. That gives me what? Minus cosine x over minus sine x. Substitute pi over 2. You have what? The minus will be cancelled. Forget about it. The minus will be cancelled. So I have what? Pi over 2, cosine pi over 2 it will be 0 over 1, and that will be 0. Okay, that will be 0. Okay, last one, number 7. Let me do it here. Limit x goes to 0, x minus sine x over x cubed. That if we check it 0 over 0. So do L'Hopital's rule. I have 1 minus cosine x over 3x squared. Substitute, cosine 0 is 1, still 0 over 0. Do it again. Limit x goes to 0. 1 minus cosine x, that gives me what? Sine x over 6x. Substitute, I'm getting 0 over 0. You can now do sine x over x, or you can complete it, do L'Hopital's rule again. You have cosine x over 6, substitute, you're getting 1 over 6. So that will be the limit. Okay. Now these are cases for 0 times infinity. 0 times infinity. What you will do, you need to take something, I mean, to the denominator. So this one, first, I have 0 times infinity. Because ln 0, that will be minus infinity. 0 times infinity, 0 times minus infinity, the same idea. So I have limit x goes to 0 from right. I will take x to the numerator. If I take 1 over ln x, that will be very complicated when you differentiate. That will be the division line. Okay, so I have limit. I can apply L'Hopital's rule. Derivative of the numerator, 1 over x. The denominator, minus 1 over x squared. Simplify it. That gives me what? Minus x squared over x. So it will be limit x goes to 0 from right of minus x. That will be 0. That will be 0. Okay. Evaluate this using 0 times infinity. E to the power minus x over square root of x. If we check that e to the power minus infinity, which is 0 times infinity, it's this category. So what I will do, I need to manipulate it. I have function over function. Easy for me to take e minus x to the down step to the denominator. They are the same. Now I have function over function. Check when you have function over function, you can always check that will be infinity over infinity. I can apply L'Hopital's rule. So I have what? 1 over 2 root x over e to the power x. Where I can simplify this one as 1 over 2 root x e to the power x. So this is infinity. This is infinity. So 1 over infinity, that will be 0. So the answer is 0. The limit is equal to 0. Okay. Yeah. Now I have the powers. Don't forget the powers. We have these 3 cases only. As I said, it comes from here. This limit give me 0 times infinity. These are the 3 cases where I have the limit goes to 0, 0 times infinity. 0 to the power 0, infinity to the power 0, 1 to the power infinity. Don't forget 0 to the power 0, infinity to the power 0, 1 to the power infinity. Okay. Check this one. You have 1 plus 1 over infinity 0, so it's 1 to the power infinity. I can apply Lewis' rule. What you will do, I will write y is this function. Y is this function. Take len y will be x, len of this. Take the limit, as this goes to infinity, of len y. I'm finding the limit for len y. Don't forget. That will be the limit, as this goes to infinity, x len 1 plus 1 over x. That will be infinity times 0. Well, I have 1 over infinity 0, 1 plus 0, 1, len 1 is 0. I need to have this category. So it means I need to rewrite it. I do this, take x to the numerator, so I have 1 over x. So now if you do it, you have 0 over 0. So apply L'Hopital's rule. You have what? This is 1 over 1 plus 1 over x times its derivative over minus 1 over x squared. This one, I can rewrite it, change it into product times the opposite of this, which is minus x squared. There's circling this. That give me what? These cancelled. I have limit. It goes to infinity, 1 over 1 plus 1 over x. So I'm getting what? 1 over 1 plus 0. That will be 1. Is my answer 1? No. I have the limit of len y is equal to 1. So what will be the limit? As this goes to infinity of y, it will be e to the power l, which is 1 in this case. So my answer is e. So the answer for this one is e. This is e, not 1. Okay. Another problem. What is sine x to the power x? Do the same. First, I will define y equals sine x to the power x. Take len y will be x, len sine x. Take the limit as it goes to 0 from right of len y. That will be limit x goes to 0 from right, x, len sine x, like what we did before. I will take x to the denominator. I make it 1 over x. Over 1 over x. Now, if you apply, you have infinity over infinity category, plus minus, who cares? Okay, so that I can apply Lewis's rule. I have what? That will be over sine x times cosine x over minus 1 over x squared. This limit is what? Limit it goes to 0 from right. This one I can take it upstairs. That will be minus x squared cosine x over sine x. Where this one, I can rewrite it minus x times x cosine x over sine x. This one, I know the limit as it goes to 0 is 1. So I have minus 0 times 1 times cosine 0, which is 1. So the answer is 0. So my answer, limit x goes to 0 from right of y will be what? E to the power 0, which is 1. So the answer of this limit is 1, not 0. E to the power L, since I'm doing the limit for len y. Okay, more problems for the power. Let me do the calculation here. Check first. By the way, here I forget to check. Here it will be 0 to the power 0, which is one of the category. Okay. Let me write them again. Okay. So here I check. It will be 1 plus 0. Cotan x as it goes to 0 from right, that will be infinity. So it's 1 to the power infinity. So I take y equal all of this to the power cotan x take ln y, that will be cotan x times ln 1 plus sine 4x. Okay, so I need to find the limit. This goes to 0 from right of cotan x of ln y. That will be limit is goes to 0 from right of cotan x ln 1 plus sine 4x. Okay, I need to make it function over function. So one idea, I can write cotan as tan. So it will be 1 plus sine 4x over tan x. Check, I have 1 plus 0, so I have 0 over 0. I can apply Lewis' rule. So that will be limit, x goes to 0 from right. That will be what? Be careful here. 1 plus sine 4x. I have cosine 4x times 4. The derivative of the things inside the argument of the ln, I have cosine 4x times 4. All over secant square. Now, if I substitute, you're getting what? Cosine 0, we have 4 over 1 plus 0 over 1 over 1. So the answer is 4. But my answer, limit, as this goes to 0 from right, of y is not 4, is e to the power 4, since I'm doing it ln y. So this is e to the power 4. That will be my answer, which is e to the power. Okay. I think we are doing fine. So the answer is e to the power 4. Doing this, 0 to the power 0. We'll do the same. That I think is easy. X to the power x. So ln y is x ln x. Need to find the limit for this one. I have the limit x ln x. So this is 0 times infinity category. So I need to manipulate it. I have ln x over 1 over x. Use L'Hopital's rule, where I have what here? Infinity over infinity. So I have 1 over x over minus 1 over x squared. That will be 0. Very clear. That will be minus x squared over x, which is minus x. That will be 0. So the limit, as this goes to 0 plus of y, since I'm doing it for ln y, that will be e to the power 0, which is 1. So this limit equals 1. Okay. Now we are going to infinity time, infinity minus infinity. Let me do this one. Yeah, I have this one will be infinity minus infinity. So I need to make it function over function. Always think of this. You need function over function. So this is the limit. It goes 1 from right. Just have common denominator. X minus 1 minus ln x over x minus 1 times ln x. Substitute, you have 1 minus 1, 0 minus 1. That will be 0 over 0. Okay, do L'Hopital's rule. I have what? 1 minus 1 over x over. Here I have product rule. Derivative of the first 1 times ln x plus x minus 1 over x, which I can simplify as x minus 1 over x over x ln x plus x minus 1 over x. This is cancelled. So I have limit x goes 1 from right, x minus 1 over this. Substitute, I'm getting 0 over 0. Okay, do it again. I have what? 1. Here I have what? Product rule. Derivative of x is 1. So I have ln x plus x over x, which is 1, plus 1. Okay, substitute. We're getting what? This is 1, huh? So I have 1 over ln 1, 1 over 0, plus 1 plus 1. That will be what? Half. So that will be the limit. Do it here the same. If you check, I have infinity minus infinity. Okay. That will lead me to what? I can take e to the power x common factor, because I need to make it function over function. Huh? That will be 1 minus x over e to the power x. One trick I do, I will take this, do the limit, then I can distribute the limit. Limit x goes to infinity, x over e to the power x. If you do it, that's infinity over infinity. I can apply L'Hopital's rule. We're getting 1 over e to the power x, so the answer is 0. So this limit, e to the power infinity, which is infinity, 1 minus 0, I get it from here, so it will be infinity. That one will be infinity. I think we did good number of problems. This one is power, and this one is infinity. Okay. Let me do more problems. This one, secant x. If you do it, you have infinity minus infinity. So I'll do the limit. This goes to pi over 2 from left. I need to make it function over function. One way, change it into sine over cosine. Into sine and cosine. That will be 1 over cosine x minus sine x over cosine x. Okay. That will be limit. X goes to pi over 2 from left. 1 minus sine x over cosine x. Pi over 2, that will be 0 over 0 now. So I can apply L'Hopital's rule. I have function over function. That gives me what? Minus cosine x over minus sine x. That will be 0 over, yeah, minus will be cancelled, huh? Over 1 or minus 1, who cares? That will be 0. So the answer is 0. The answer for this one is 0. Okay. Now we'll do more problems. I have this list of problems. Let me try to do them. I don't have space, but it's okay. I will try to squeeze them here. Here I have what? Infinity times e to the power minus infinity, which is 0. So I have infinity times 0. 0 times infinity, this one. Number 1, let me rewrite it here. X squared e is x. So this one will be infinity. And this one is minus infinity and who times 0. So I have this category. Infinity times 0 or 0 times infinity. Okay. Okay. So I need to take someone downstairs. So I will make it, I think, x squared over e minus x better. Yeah. And I can check it here. Now it's infinity over infinity. Where I can apply L'Hopital's rule. You have limit. It goes to infinity to x over minus e minus x. Check. It's still infinity over infinity or minus infinity. Who cares? You know, we are looking for the category or the type. So I don't care plus or minus. I have 2 over e minus x. That will be what? C. And 2 over e to the power infinity, which is infinity, 2 over infinity, that will be 0. Also, the limit is 0. 2. Number 2, let me try to do it here. Hopefully I can squeeze all of these 6 problems. I have x tan 1 over x. Tan 0 is 0. That will be infinity times 0. So try to manipulate it. I make it tan 1 over x over 1 over x. What will be the derivative? Now it's 0 over 0, huh? Now it's 0 over 0. I can apply L'Hopital's rule. Limit goes to infinity. You have tan 1 over x, which is secant squared 1 over x times minus 1 over x squared over minus 1 over x squared. Had it cancelled? Secant 0 is 1, so that the answer is 1. That will be my answer. 3. Limit, as it goes to infinity, x minus ln x. If we substitute, you have infinity minus infinity. Okay. One way to do it, I take x or ln x as a common factor. I can take x. I have 1 minus ln x over x. Like what we did with this one. I'll do the same. I take this, do it alone. Let me do it here. Limit as this goes to infinity of ln x over x. Substitute, I have infinity over infinity. Differentiate. We're getting what? 1 over x over 1. So the answer is 0. So this is 0. So the answer is infinity. 1 minus 0. And that will be infinity. Number 4. I don't know. Can I squeeze them here? Let me check. Now these powers, limit is goes to 0 from right, and to x to the power x, which is 0 to the power 0. What I will do, I'll make it y. So I have ln y x times n tan to x. Now I'll find the limit as goes to 0 from right of ln y. That will be the limit as goes to 0 from right of x ln tan to x. That will be 0 times infinity. Would agree. So I will take x to the denominator. So I have ln tan to x over 1 over x. Okay, now I'll use L'Hopital's rule. Notice I have infinity over infinity here. So I have in a tan to x. I have what? In the numerator, I have secant square to x times 2. كله على minus 1 over x square. Okay. That will take me to what? That will take me limit x goes to 0 from right of minus 2. I'll take this to the numerator, minus 2x squared, secant square 2x over tan 2x. Okay. What you will do, I can rewrite this. Limit x goes to 0 from right minus x secant square 2x times 2x over tan 2x. Notice this one, I know it from the special limit as it goes to 0, this is 1. So the answer is minus 0, secant 0 is 1, square is 1, times 1, and the answer is 0. So the limit as x goes to 0 from right of y, the tan to the power 2x, will be e to the power 0, which is 1. So the answer of this limit is 1. It's not 0. It's 1. 5. I don't think I can squeeze it here. Let me add 1 page. Okay. Yeah. That will be limit x goes to infinity. Number 5. Limit x goes to infinity. X to the power. X to the power. Ln 2 over 1 plus ln x. Which is what? Infinity to the power 0, huh? This is infinity, ln 2, ln infinity is infinity, ln 2 over infinity, that will be 0. So it's infinity to the power 0. Okay, is it? Yeah, okay. Now we'll do the same thing. I have y equal x to the power ln 2 over 1 plus ln x. Take ln y, let's say ln y equal ln x. Let me do it in steps so to avoid any confusion, which is equal to ln 2 over 1 plus ln x times ln x. In other words, it's ln 2 times ln x over 1 plus ln x. So this is ready now. It's function over function. No need to move something down or okay. So now the limit as this goes to infinity of ln y is the same as this limit, which is ln 2 times ln x over 1 plus ln x. You apply it, you have infinity over infinity. But I have ln infinity over ln infinity. Okay. So apply Lopez's rule. You have what? Ln 2, this is the number, over x, over 1 over x. And the answer is x cancelled. I have ln 2. So what will be my solution? My last answer of y will be e to the power ln 2, which is 2. So this limit equals to 2. Okay, let me do number 6. Last one in this group. Where is it? Limit x goes to 0. Cosine 3x to the power 5 over x. Very clear, that is 1 to the power infinity. 0 from right, I think it should be 0 from right. So I have infinity there. Okay. So I'll do the calculation. Y equal cosine 3x to the power 5 over x. A minute. 5 over x. I take ln. That will be 5 over x. Ln cosine 3x. Yeah, I don't think make a difference if it is plus or minus. Huh? Let me check here. That will limit x goes to 0 of ln y. That will be limit x goes to 0. 5 ln cosine 3x over x, which is 0 over 0. So no, it's okay. X goes to 0 is okay here. So 5 ln 0, cosine 0 is 1. So 1, which is 0. So it will be 0 over 0. So it's ready. Limit x goes to 0. I have what here? 5 cosine 3x. And they have 3 sine 3x. They have 3 sine 3x. With a minus sign, yeah. Is it? Yeah, 1 over cosine 3x over times derivative of cosine 3x, which is minus 3 sine 3x. Okay, all of this over 1. Now this is the numerator and this is the denominator. Okay, now I substitute what you will get. Sine 0, which is 0. All of this is 0. So the limit as this goes to 0 for y. This is ln y. It will be e to the power 0, which is 1. So the limit, all of this limit is 1. Did I do any mistakes? Ln, I have 5 ln over x, which is 0 over 0. That will be 1 over cosine 3, 5. 1 over 3 cosine 3x times this derivative, which is sine 0, will be 1. Will be 0, sine 0. Sine 0 over 1 will be 0. We'll do more problems here. I have e to the power x plus x to the power 1 over x. Yeah. These are more examples, I think, from the book. Okay, we'll do it. I have what? Okay. This limit. If you do it, we have infinity to the power 0. So it's one of the category. So we'll take y. Yeah, it's infinity to the power 0. So we'll take y e to the power x plus x to the power 1 over x. I try to solve it here. I'm not sure I can, but it's okay, I'll try. So that will give me ln y is 1 over x ln ax plus x. That implies the limit as it goes to infinity of ln y will be the limit as it goes to infinity of ln ax plus x over x. That's very clear, infinity category. So that equal limit as this goes to infinity. Differentiate this. I have ax plus x, and I have ax plus 1 all over 1. Substitute, that will be limit, x goes to infinity, ax plus 1 over ax plus x. If you look at it, you have what? It's still infinity over infinity. Do it again. So you have a limit, x goes to infinity, of what? E to the power x over e to the power x plus 1. Still, I'm having infinity over infinity, correct? Yeah, substitute, I have infinity over infinity. So do the limit again, L'Hopital's rule again. I have e to the power x. Actually, I can take e to the power x common factor, but let me do L'Hopital's rule. I have e to the power x, e to the power x, so I'm getting 1. So what will be the limit as it goes to infinity? This is ln y, of y, that will be e to the power 1, which is e. So this limit equal to e. Okay. Now I have this, which is 0 times infinity category. Let's find the limit. That will be limit. It goes to 0 from right. I need to take something in the denominator, so I'll make it ln x over cosecant x. Okay, so it's infinity over infinity category. So that will be limit. X goes to 0 from right, 1 over x over minus cosecant x cotan x. Okay. Now that will be what? That you can do as a limit. X goes to 0 from right of what? This cosecant is 1 over sine. So it will go up as sine x over x over minus cotan x. Or cotan, I can make it. Let me do it. That will be 1 over x. Everything make it in terms of sine. That will be minus 1 over sine x v cosine x over sine x. Okay. That give me what? Limit as this goes to 0 from right of what? Yeah, make it very complicated. It's 1 over x times the opposite of this minus sine square over cosine x. The reciprocal of this, I mean. X goes to 0 from right. I can make this minus sine x over x times sine x over cosine x. This limit is minus 1 or 1 minus times 1. And this limit 0 over 1. So the answer is 0. So what is the limit? Plus. So the limit is 0. No need for E. This one. Okay. I think we did some problems. Now let me check this one. Or I'll just leave it. Yeah, I think I will stop here and I'll continue from this one, inshallah, next. Okay. The recording. Thank you.